In 1947, programming a computer meant rewiring it by hand until one woman changed everything. Imagine a world where every time you wanted to run a new program, you had to physically rewire a machine the size of a room. No screens, no keyboards, just switches, cables, and endless frustration. This was the reality of computing until Kathleen Booth wrote a book that taught machines to speak. She created the first programming manual. Why don't you know her name? Born in 1922 in Starbridge, England, Kathleen Britton was a mathematician, a quiet genius in a post-war world that rarely celebrated women in science. She earned a PhD in applied mathematics, unheard of for a woman at the time. But it wasn't just numbers that fascinated her. It was how logic could be applied to machines. In the 1940s, computers weren't personal. They weren't even machines as we know them today. Computers were colossal, mechanical beasts. They were vast, experimental with vacuum tubes, punch cards, and endless wires. Programming them wasn't just hard, it was a physical ordeal. In those days, there was no Google, no tutorials, no documentation. People were just trying to figure out how to make a machine think. Scientists like Kathleen Booth spent hours, even days, rewiring machines just to perform basic math. But Kathleen saw a flaw in the system, and a revolutionary idea began to take shape. When World War II ended, she and her husband, Andrew Booth, joined a team at Birkbeck College, University of London, working on something that would shape history, building a computer from scratch. While working at Birkbeck College, she and her husband Andrew built some of Britain's first computers. But Kathleen faced a challenge: how to make these machines easier to control. Her answer? A language that bridged the gap between humans and hardware. She became one of the very first people to write systematic instructions on how to tell a computer what to do. In 1947, Kathleen invented contracted notation, the world's first assembly language. No more rewiring, just simple commands like load and add. But she didn't stop there. In 1958, she wrote the first known programming manual called Programming for an Automatic Digital Calculator, a book that would become the Bible of early programming. To understand how revolutionary this was, imagine you're staring at a massive machine the size of a closet. No screen, no keyboard, no interface, just a wall of blinking lights and endless wires. Now imagine trying to tell it to calculate anything. That's where Kathleen's manual came in. She didn't just list commands. She wrote down how to write memory-efficient programs, how to represent logic with symbols, how to structure instructions for early CPUs. In other words, she built the bridge between human logic and machine execution. She turned theory into readable instruction. Kathleen's manual didn't just explain how to program, it taught a generation how to think. For the first time, complex tasks could be broken into logical steps. Kathleen wasn't just a writer. She was also a programmer and co-inventor. Working with Andrew Booth, she helped develop one of the earliest computer architectures, the Birkbeck Type Machine, BTM. They also introduced the Booth multiplier algorithm, a technique still taught in computing courses today for efficient binary multiplication. These weren't theories in a lab. These were real contributions that shaped the first generation of machines. And behind many of these breakthroughs was Kathleen's mind. Kathleen's work didn't stop in the 1950s. She taught computer science for decades. She researched machine learning long before it was mainstream. And she watched the world go from punch cards to mobile phones to the internet. While most of the tech world moved fast and forgot, she stayed the course. Her last known publication was in the 1990s on neural networks. Still building, still teaching, still coding. Her work laid the foundation for every programming language we use today, from Python to JavaScript. But here's the twist: Kathleen's pioneering work was nearly erased. When her husband was denied a promotion, they left Britain abruptly. Her legacy faded until now. Kathleen's story is one of brilliance and betrayal. Despite co-founding Birkbeck's computing department and pioneering machine translation, she was overshadowed. When the couple moved to Canada, her contributions were buried under the sands of time. Yet even in exile, she kept innovating, publishing her final paper at age 71. Kathleen Booth didn't ask for attention. She just picked up the pen and wrote the first draft of our digital future. Her programming manual helped define how logic could live inside a machine. She wrote the blueprint for every programmer that came after her. In the early days of computers, when many were still wondering what these machines could do, Kathleen was asking how they should do it, and answering it line by line. Without her, the language of computers might still be locked away, unspoken, unsystemized. Every time you use an app, play a game, or scroll social media, you're standing on Kathleen Booth's shoulders. Her manual taught us how to speak to machines, and without it, the digital age might never have dawned. So, if Kathleen Booth helped invent a computer, wrote the first programming manual, and contributed to one of the most fundamental math algorithms in computer science, why isn't she a household name? The answer, as with so many brilliant women of her time, is simple. She was ignored. Her contributions were overshadowed by male colleagues, even though she was often the first author on academic papers. Histories of computing often cite her husband, while forgetting she was writing the code. So now we remember her. Because some geniuses don't need a spotlight, just a keyboard, and the courage to document the unknown. Kathleen's story reminds us, innovation has no gender. It's time to rewrite history. If you believe forgotten pioneers deserve their spotlight, smash that subscribe button so together we can find out who else shaped our world from the shadows.